stupid.
You don't know how to get the hell out of here.
Are you always the first? Are you always the first?
تتعاركوا ندفع فيه. It's very expensive this. I'm paying a lot of money. And you تتعارك. العادات. أعمل وليش شو خريط ألا شو خريط.
مي اوكي.
وين نعدل في الماء نزيد الماء وين قلنا
ما يمشي تو كريم.
آخر حاجة الماء كمان.
لا جمال الخدمة.
My number is multiple of 2.
I don't know.
My number multiple of 2. My number is multiple of 7.
28.
Common factor of this number. Give me common factor. 6 and 8. Common factor يعني. يعني عامل فاكتور بتاع 6 واحد.
Thank you, Brian. ارجع الخدمة. تشوف تعارك. Where do you go? Yeah, I'm studying. Okay. نهار اسود. That's too much. Not too much. What's too much? What's too much? What's in my mouth in America? What's too much? What's too much?
Too much people drunk.
No.
26 already.
Tap.
I guess we're gonna have to study with them today. Anna, can you do this?
جنت أو جنت.
Hello.
Hello, ma'am.
Hi, Minna. Hi, Saif. Omar. Oh, there is other Omar. Oh. Hi, Omar. Omar Hazza. It's called also Omar Ahmed. Okay. Hi, Angie. How are you? Hi, Khalid. Hi, Aman Allah. Hi, everybody here also. What we do today, we have some homework about the extraction of metal and the redox. But I will explain the redox first, and then I will do homework about the extraction of metal. Okay? Let's see what we have today about this chapter. Redox, let's understand the meaning of this word. Redox, reaction. Redox, it means we have, there is other girls didn't join. Where is Helia? Where is Juri? Where? Okay. So let's talk about the meaning of this word. Okay, if you divide the word, it is reduction and oxidation. Okay, so we have to understand first what is the meaning of oxidation and reduction. If you define oxidation, opposite it is a reduction. Let's start. Oxidation is what, and we write down an example. Where reduction it is what, and we do an example also. Oxidation it is addition of oxygen. Addition of oxygen. So let's see an example, and you can explain what kind of reaction if you see that. If you have this material, carbon, we saw carbon or coke in the extraction of iron, right? So if you add oxygen to this carbon or coke, what we get? We get carbon dioxide. What is the meaning of that? It means carbon get oxidized. A reason, gaining of oxygen or addition of oxygen. So very simple definition here for this one. I repeat again. The meaning of oxidation, it is just addition of oxygen. We add oxygen. If they give you underlying material, so this one get oxidized. Explanation, I need all of you to understand. Then you write down in your own way, all right? So addition of oxygen. Next one, reduction. Reduction, the opposite of addition is what? Removal. Removal of oxygen. It's okay, Yanada. Accept removal of oxygen. Let's see, for example, we saw this equation, copper oxide plus carbon. Carbon will remove oxygen, forming what? Copper alone plus carbon dioxide. So what happened to copper oxide? Reduced, reduction. A reason it's what here you add removal of oxygen. You have to know explanation. What is going on? In this equation, we added oxygen, addition sign over here. But here it is removed. Copper here, it is free from oxygen, so it is reduced. Yes. Next point, Aman Allah, yes, you wrote loss of electron. Oxidation is loss of electron. Inshallah, next time I will explain the electrolysis chapter. Electrolysis, we need this part. That's why I say let's do a redox first. All right? So loss of electron, let us do an example. What is the loss of electron? For example, if I have magnesium forming magnesium ion, and we get here 2 electrons. What happened here to magnesium? It is oxidized. But you can't say because we added oxygen here. What is the reason will be? Loss of electron. Because it's already lost the electron. All right? So according what you have in the equation, if there is oxygen added, you say this reason. All right? What you have in the equation exactly. Here, there is oxygen added to this carbon. If that is the explanation you give to the question. Don't say loss of electron in this case. All right? But in this case, there is no oxygen in this equation. What happened here? Magnesium lost the electron, so it forming magnesium ion. So the explanation for the oxidation in this case, a reason it is different. So loss of electron. About the reduction, instead of loss, it's what? The opposite. Gaining, very good. Gaining of electron. Gain of electron. Let's do an example. For example, if I have Al positive 3, we saw this equation when? Electrolysis of aluminium plus 3 electrons, what we get? We get aluminium metal. Let's see what's happening here. It is a reduction, a reason, because aluminium ion gained electron. So according to the data given in the equation, you have to explain this way. All right? So I repeat again, oxidation, addition of oxygen, if it is shown in the equation, if it is available in the equation. If it is not mentioned in the equation, no need to say that. All right? And if the equation here shows that there is loss of electron, that is your explanation. Okay? And a reduction, it is the opposite, removal of oxygen here from copper oxide to get copper. So copper oxide reduced. With this one gain the electron, I'm talking about what? About the aluminium ion. The aluminium ion get reduced. A reason, it's what? Gaining of electron. Last, second or third explanation with this important, because it is introduced from the AS level. It is what? Oxidation number increases. Oxidation number increases. What is this oxidation number? It is a charge. It is a charge. I will give you an example, and also we will see how to calculate an oxidation number for a known element. It is a new part this year. It is a minor change in your syllabus. So expect it as a question, Ya Fatima, in your exam. Don't sleep. Pay attention. Go wash your face. All right? Now. Yeah, we will give more examples. So we didn't start yet the equation. Oxidation number increases, so it is oxidation. We will give example now. About this one, a reduction is opposite. Oxidation number decreases. What is this oxidation number? It is a charge, but we have to get an idea how to find it. For example, okay, assume I have this copper. It gives copper plus 2 electrons. What is the charge on this copper? Zero, nothing. It's okay, no problem. Even it's wrong, at least you try. So it is 0 charge. So oxidation number for any element in the periodic table, there is no charge. We said that it is 0. It is neutral. Any element in the periodic table, it is neutral. All right? So what is the value here? Positive 2. So what happened to the charge or oxidation number? Increases. You get it? It is so simple. Very simple. No, you can say loss of electron, but if he said in the question using the oxidation number change, so you say here oxidation number increased. You may say increase from 0 to positive 2. It is a new part again. Bi'Iznillah, it's a question in your final exam. What about a reduction? Let us do another example. For example, I have the same example of aluminium ion plus 3 electrons. I get aluminium. What is the oxidation number of aluminium ion? It is positive 3. What is this one? 0. Very good. So what happened to the oxidation number? Decreases. So briefly, it is a value of the charge. All right? I repeat again, and then I give an example about redox reaction. And first, we start to calculate an oxidation number. The definition of oxidation, it is either addition of oxygen or loss of electron or oxidation number increase. Loss of electron here, ya Joanna, what happened to this magnesium? Forming magnesium ion by loss of electron. After the arrow, we have this electron. All right? So this electron after this arrow, it means the magnesium lost this electron. We saw that in the bonding. The metals lose, all metal lose electron to form a positive ion. All right? So this loss of electron, that is the explanation why the magnesium it's get oxidized. Magnesium oxidized to magnesium ion. Either you can explain by loss of electron because it's formed here magnesium ion, okay? Or the oxidation number, it was 0 and now becomes positive 2. Increase. No need to mention a value. Okay? With reduction, it is the same exactly concept, but the opposite. So here addition of oxygen, removal of oxygen. Here loss of electron, here gaining of electron. Oxidation number increase as oxidation number decrease. All right? Let's see about the periodic table. If we are talking about the periodic table, we know that all elements in the periodic table are what? Neutral. All, they have no charge. Okay? But we can get a charge if they are a compound, if they are bonded in a compound. For example, if you are talking about any of this element, it is 0 charge, no charge. When we can find the charge? If for example, if I have sodium chloride, if you break down this one, this positive one and this negative one, so yeah, exactly. So it has, we understand that group number 1, it's positive 1. Group number 2, positive 2. Group 3, positive 3, mainly aluminum. And then forget group number 4 and the group 0. Group 0 or group 8, it is 0 charge. Yes. Then group 7, negative 1. Group 6, negative 2. Group 3, negative 3. 5, sorry. Okay? That's the value of the charge. Let's see. You have a question? Transition metal?
لا 4.
It is plus minus 4. We'll talk about it. Okay? Let's see how to find the oxidation number. بإذن الله, it is a question in your exam. It is the first time since 20 or 30 years when they started the IGCSE, they didn't give for the O level. For your level, this year, you will get question about it. It is so simple. Okay, we understood that the element in the periodic table, they are neutral, 0 charge. But assume, then we go to the redox reaction. But this part, new for your level. I'm teaching that for the higher level. But for you, it is just calculation of the oxidation number or charge. Assume they give you this material, H2SO4. Pay attention, please. I need to find the oxidation number of sulfur. Don't go to the periodic table. So is sulfur unknown? This is unknown oxidation number. Well, hydrogen from the periodic table, it's positive 1. Well, oxygen group 6, negative 2. So I will substitute. How many hydrogens we have? 2. 2 times positive 1. Okay? Well, sulfur is unknown. Well, oxygen, how many atoms? 4. So 4 times negative 2. A total charge, it's what? 0. So you can find the oxidation number of sulfur now equal positive 6. Well, please write down a sign, either plus or minus. I repeat again, how to find the oxidation number. You see this sign? Once I write it down, expected in your exam, not only in any quiz in your school, in the final exam, inshallah, in summer. Okay? So we will practice that together. Don't worry. We will solve homework about the redox. Plus, I will send the question about calculation of the oxidation number. From a specimen of year 23, the specimen sample, we have homework about it today, but not about the redox. But I will send the question how to find the oxidation number. I repeat again, how to find for sulfur, for example. Let's practice more. If I have 4, if I need to calculate for SO3, but I need to calculate for الsulfur. Oxygen group 6, so the value how -2. All right, so I substitute sulfur unknown will oxygen how many? 3 times -2 equals 0. So also oxidation number will get it +6. All right, a sign please. If I need to calculate for SO2, but only for sulfur, same way, sulfur, I have 2 oxygen atoms only. 2 times -2 equal the total value of the charge 0. So we get +4. Whatever value you get, write it down. It will be different in any compound. It is not the value from the periodic table. All right? If you calculate here a value in any compound, it is never same like sulfur is group number 6, so -2. So we get here +6 and we get +4. We may get different value, no problem. Okay, let's see if we have an ion, SO4 -2. Same way as sulfur unknown, oxygen 4 atoms times -2. What is the overall charge now? -2, not 0. Okay, so if you have a charged particle like positive ion or negative ion, calculate the value. We still get +6. All right? Now I will give other product and I will ask Aman Allah to tell me how to calculate. I need to calculate يا أمان for النيتروجين النيتريك acid. الهيدروجين is +1 والأكسجين -2. يلا يا أمان الله.
First of all هتعمل
Raise your voice حبيبي to hear you.
1
الهيدروجين is +1. Okay.
So,
Then
plus N.
Plus N. Oxygen, it is -2 from the periodic table. How many?
Plus 4 brackets
3 times -2. I have 3 atoms of oxygen -2. We have any charge here on the particle?
Yes.
What is the charge? The overall charge for nitric acid. What we write down here after?
It will become
0.
0.
0, no charge. 0. All right? So you get an oxidation number of this nitrogen equal +5. It is different than the value in the periodic table. It is different. Okay? Yalla ya Adam, your question. Which one? It is mathematics, ya Adam. Okay, I will do this step again. What we have here? This -6 and this +1. So now, if you subtract the 1 from a -6, it will be -5. So this value will be on this side. Math. I can teach you mathematics, by the way. Yalla, do this particle with me. Now this nitric acid. If I am calculating for nitrogen and ammonia atom, hydrogen is +1 from the periodic table. I need to calculate for a nitrogen. +1 times 3 equal, what's the total value charge?
-3.
Why -3? 0 to get the value first. This is the equation. You show your work in the exam. So oxidation number, he is in hurry. Equal -3. Please, calculation of the oxidation number, either positive or negative, you have to write it down. Important. If you forget to write down the plus, you will not get the mark. You will get it in your exam. Let's practice more. Here, safe. I have NO2. I need to calculate for a nitrogen in this material. Well, oxygen -2. Plus 2 times -2 equal, what's the overall charge? 0. So nitrogen here, what we get? This side, Adam, it will be +4. 2 times 2. You will lose marks because you are in hurry. 2 times 2. I know my handwriting is not good. Yes, ya Muhammad, you have a question? You're online today. Muhammad, you have a question? Why you raise your hand?
Miss, I have a question.
يلا
If
حبيبي.
the examiner tells me you have ammonia, calculate N. Do we write NH3 plus or NH3 only?
Ammonia, it is neutral. Ammonia, it is different than ammonium. We will do ammonium now. But if he said this name, ya Muhammad, ammonia, it is neutral. Ammonia, okay? So it is NH3, nothing on the top. It is 0, as I write down here. فالoxidation number of nitrogen will get a 3, -3. Let us do now for ammonium ion, ya Muhammad. You will do it with me. NH4 plus. This what? Ammonium ion. So we substitute about the hydrogen. How many hydrogen? Muhammad. Plus 4 times plus 1.
Plus 1 is
That is
equal
that
to
hydrogen. But the overall charge, how much now?
plus 1.
Plus 1. Very good. That's it. And just you calculate for this equation.
-3,
Now,
fine.
what we get? So, N. Okay, Adam, pay attention. I have plus 4 equal +1. So this plus 4, it will become in this side. It will be -3. You can do this kind of calculation, Adam, right? So in nitrogen here, in ammonium, it will be -3, right? If I'm talking about the nitrogen. So we know now how to calculate the oxidation number. I repeat again, it is a question in your exam. It is introduced only this year. يلا يا فاطمة. You didn't get? Okay, روح. Okay, Shabab, anyone didn't get? Anyone has a problem to understand that? What about you, Omar? It's the first time for you to join this group. This student already, they got maybe this number 10 today. Class number 10. Omar, you have...
Yeah, I really understand this one.
Okay, Habib. Okay. Anyone didn't get this part? Let's get now للredox reaction. Let's understand what is the meaning of redox reaction. Because I prefer all of you to use this statement. Oxidation number increases or decreases. All right? That is the best way for you. It is easy to mention that. Let's write down an equation, and you have a summary of the chapter is very short. Very short. Well, exactly, it is the same in the AS level and the A level, if you will continue, but with more advanced data. Electrolysis, it's a little bit hard. لا, different, separate chapter. Next time, inshallah, we'll start. Okay, let's start with very simple equation. We saw this equation in our extraction of iron. Okay, I have this equation, and they ask something, I will tell you about it. Okay, it is redox reaction. Okay, what we have here in this equation, we have oxygen. We have oxygen in the hematite, in Fe2O3. What happened here to the hematite? Lost to oxygen. Lost to oxygen. It is very clear in this equation that an Fe2O3 lost to oxygen. So it is what? Reduction. This root was the best way to explain a redox. Make one root. That's the root A. Okay? What happened to Fe2O3? Lost to oxygen. What about the CO? It has one oxygen here, but the CO2, it has 2. So addition of oxygen. So a root number B, it is oxidation. What reason? It's what? Addition of oxygen. Because original oxygen, it is very clear here in the equation. So an overall equation, it is redox reaction. Redox. What is the meaning of redox? This material get reduced, with this material get oxidized. I have reduction and oxidation in the same equation. That's the definition. Clear? We will practice more. But when you get this question in extraction of iron, they will ask you to write down redox reaction. They will tell you, describe how to extract the iron. I repeat, yes, Alma. So repeat this one, it is reduced, Fe2O3, because it lost oxygen, it gives me iron alone without an oxygen. While the carbon monoxide, it is oxidized because gained oxygen. So the overall reaction, it's what? Redox reaction. This one I added, it gained oxygen or addition of oxygen. We have here one O, I have O2. So it gained oxygen. Regarding this Fe2O3, what happened? The oxygen gone. Removal of oxygen. According to the data. Let's see another equation. For example, if I have zinc plus copper ion, all right, it will give copper plus zinc ion. Okay, I will do two routes. If you can see well, yeah, safe, change your seat, please. Okay, I will do two routes. Is zinc, what happened here? You are in hurry. When a metal form a positive ion, what happened? Loss of electron. Or we can say what? Oxidation number here, it is 0. Okay, and it becomes positive 2. No need to mention a value, at least for the O level. We can say oxidation number increases. Oxidation number increases. All right? I repeat again. Either you may mention regarding zinc, I will tell you, a root is zinc. When we study electrons, we will understand that it will form zinc plus 2 electrons, because we understand that the metals, all metals lose electron to form a positive ion. So either you say here loss of electron or oxidation number increase. Until last year, the student always used this statement, by loss of electron. But which one is easier for you? If you check a charge, this value here 0 and plus 2, so increased. That is a 0 value, and we get up. All right? So oxidation number increase, it is oxidation. All right? I will use the same idea for copper ion. What happened here? Plus 2 and 0. Either gaining of electron or oxidation number decreases. Which one is easy for you? Use it. Okay? Very good, yeah, Ange. I repeat again. It is a redox reaction, yes. What happened here? I have two routes. So that is the best way in your exam. One route, always oxidation, and the other one, it is reduction. If they ask about a redox reaction, all right? And you have to know how to figure out a reason. If we have oxygen in the equation as this example, sure, this question important in your exam, either about a redox reaction or about an extraction of iron, all right? So redox here because of addition of oxygen or removal of oxygen. Because it's very clear we have this particle. In this particle, there is a change in the number of the oxygen for the material after an arrow. You check always what we get after an arrow in the product, all right? In this equation, we don't have an oxygen, don't mention an oxygen. In this case, don't mention an oxygen at all in this equation. So either you say oxidation number increases for zinc, or oxidation number decreases for copper ion. Or in this case, if we get a positive ion, it is loss of electron. We hear a positive ion, it becomes a neutral because of gaining of electron. All right, let's practice more. We get one question from a substitution reaction of the halogen. It is very common question in your exam. For example, I have chlorine plus potassium bromide, for example. It will give bromine and potassium chloride. We will see this ionic equation later on. But to help to understand how to do this question, we break only the compound. I break down this one, always a metal positive and non-metal negative. We here also positive and negative. I make two rules. El chlorine, change it to what? To chloride ion. Either you use here, ya Yusuf, loss or gain of electron or oxidation number. Tell me what happened. Gain of electron, because here becomes negative. A sign of the electron is negative. So it is here reduction. Yusuf choose to say it is gaining of electron. Or what else we can say? Yalla say oxidation number here, nothing. If there is no charge, يبقى zero. What we have here? -1, so decrease is very good, yes. You understand? Let's see bromide ion here. Let's see bromide ion. Okay, Omar, Ahmed, here. Yalla حبيبي. What happened? This one, it is reduction. We assume this oxidation. I need to give an evidence. So what happened here? -1 becomes oxidation number. What happened?
The oxidation number decreases.
It was -1. I have another Omar Ahmed here, ya Omar. So I called you Omar Hazza, okay? Your family name is Hazza, as I saw? Yes, because I have other Omar Ahmed here at my home. So this -1, okay, Omar, here. I have -1 and become 0. How decreases? -1, that is the 0, -1 is over here. So what happened? Increases. Oxidation number increases. Or a -1, it's what? It is the electron. It lost the electron. All right? So this one, it is oxidation. Up to you. Choose a reason. Choose a reason. Let us practice more. So, yes, I will do another equation regarding this halogen, and you do it with me as well. I have fluorine. I will write down ionic equation. And 2 iodide ion. It will give iodine and 2 fluoride ion. I will do this route. The fluorine change it to fluoride ion. I suggest to use the oxidation number. If you like. Yeah, what happened to fluorine? It was 0, all right? Now what is the value? So what happened? Decreases or increases? Very good. What is the meaning of decreases? Reduction. Reduction, the oxidation number getting down. Now, the iodide ion also use the oxidation number. It was -1, it becomes 0. So what happened? Increases. So it is oxidation. So simple. That is much better than loss or gain of electron. يلا حبيبتي. You may get an equation and it is not a redox. It can be material get oxidized only. Okay? So we will go to this step, but this is yourselves, the second use. I repeat this equation again. We have material here. Well, my advice as a teacher again, use an oxidation number change. It is very clear. Any element here, diatomic halogen, we understand it is neutral. Any element alone is neutral. What's the meaning of neutral? The charge, it is 0. All right? You have negative. What's the meaning of negative? We are not writing 1 in chemistry. So -1. So what happened is the value? If it is 0 and becomes a -1, decreases. What is the meaning? Decrease. Oxidation number reduction. Now, it is -1 becomes 0. So it gets higher. So it is oxidation. It takes a few seconds in the exam. So an overall reaction, it's what? Redox reaction. Redox reaction. All right? Let's practice one more example. You may say your question, Yusuf.
In terms of
He can, yes, he can say that, yes. But I think this year they will focus about the oxidation number. Yeah. If a material get oxidized and the other material get reduced, it is redox. Okay, we see here this material, what happened to this material? Reduction. What happened to this material? Oxidation. So oxidation, reduction in the same equation, redox. Oxidation and reduction in the same equation. That's the definition. Let's do another example and then we talk about the oxidizing agent and the reducing agent. If I'm talking about magnesium displacement reaction, all substitution reaction, either الهالوجين or metals, the more reactive metal can kick or displace the less reactive one. We talked about that in the reactive series. For example, if I add magnesium to, for example, potassium nitrate, no, this never happened. Because the potassium is more reactive than magnesium. So we put, for example, silver nitrate. Magnesium plus silver nitrate, magnesium is more reactive than silver. So it will kick silver alone, and then we get magnesium nitrate. That's the formula for get the balance now. Let's see. Well, I gave you just a quick idea that any displacement reaction or substitution, it is redox. I will make it as ions to make it easy for you. What we have here, I have a silver nitrate, I break down, plus, minus. Always your left-hand side, always positive. Always positive. And this magnesium, it is positive too. All right? Again, we can balance the equation, no problem. All right? What happened now, Yasif, to this magnesium? Yalla, Habibi, what we have here? Saif Hassan, you are with us today, right? Yalla, Yasif. Saif Hassan, what happened to magnesium? Using an oxidation number.
Its oxidation number increased.
It's an oxidation number. This it was 0. You see it is neutral. So 0 value, it becomes positive 2. Oxidation number increases, so it is oxidation. We can, Yusuf ask if they tell you in the question, using electron transfer, yes. What we can say here about the magnesium forming magnesium ion, Fatima? What happened here to electron? If we need to mention electron loss or gain, if magnesium to magnesium ion, loss of electron to form a positive ion, loss of electron, it is a definition of oxidation in addition. All right? So this root A, it is oxidation. Either you mention oxidation number increases or due to the loss of electron. Let's see what happened here to the silver. Let's see what happened here, ya Angie. The silver ion. Okay? Okay. Salma answer. It is positive 1. Oxidation number decreases. Very good. So what happened? It is reduction, as Salma said. So reduction, a reason. Positive 1 to 0. Or gaining of electron. You memorized the definition. Oxidation, loss of electron, reduction, gaining of electron. So the overall reaction, it is redox. Why, Joanna? Because we have material get oxidized, material get reduced in the same reaction. All right? Let's see another important part. And of course, you can ask whatever question before we go to the homework. Okay, if I'm asking about an oxidizing agent, you have a question, Adam?
One had his electron increase, but the other one didn't have its electron increase.
It is not a redox. Assembly. They will not ask O-level questions this way. Okay? Oxidizing agent, you can check simply from the equation. It is all halogen. Halogen are working as oxidizing agent. Okay? For example, if you get chlorine, bromine, or iodine, all this material, I wrote it in your note. Enough to study from the note again. And we confirm our study to do what? Solving past paper. Everything it is written. And we have this material, we will understand the name later on. Potassium manganate, K, Mn, it's the manganese. Potassium manganate. No need to memorize the formula. Potassium manganese or potassium dichromate, K2Cr2O7. If the formula is complicated for you, just memorize the name, please. All right? What is the oxidizing agent? Just I will write down simple that oxidizing agent. We are talking about oxidizing agent. You see this word? Agent. I check what is the material get reduced, reduction. I check which material get reduced. And we will see now in the equation. Next one, reducing agent. A reducing agent, what we saw in the extraction of a metal. Like what? What is the material we saw as a reducing agent? Carbon, very good. Or carbon monoxide. Or hydrogen or ammonia. All this material works as a reducing agent. Mainly we saw coke and the carbon monoxide. Okay? It is the same. All right? Now, how to find the reducing agent? We check the material reducing agent. You see, I write the agent like this way. I check the material get oxidized. Let us do that easily together. How to find an oxidizing agent or a reducing agent? I go to any equation already with that. For example, this equation. For example, what happened here to this zinc? Is zinc, it is oxidation. So, the opposite to oxidation is what? If I'm talking about agent, reducing agent. It is not reduction agent, reducing agent. So I will check again which material get oxidized. It works as reducing agent. Exactly. The material get reduced, it is what? Here it is oxidized. Oxidation, it works as reducing agent. Explanation. How to justify your answer. Same explanation why you said zinc, it gets zinc plus 2. Either oxidation number increases or by loss of electron. Either one. So no new reason. It is the same reason exactly because of the oxidation. Next one, copper ion, it is what? Change it to copper. So it is reduction. Agent, it will be what? Oxidizing agent. Very good, Joanna. Oxidizing agent. So opposite, what happened? Oxidizing agent get reduced. A reason again, oxidation number here decreased. Same explanation for oxidizing agent. Let's do a more equation from 0. We'll see which material get oxidized. I write down like this way. A plus B, okay? I get A plus and B minus. What happened to A in the point of oxidation number? So it is oxidation. Very good, Yanada. Oxidation or reducing agent. You see, it is so simple. Reducing agent. An explanation here, ya Adam, it's what? Oxidation number increases. Very good. So simple. You see the value of the charge. Here is 0. Now it is plus 1. Now, ya Khalid, what happened to B? It is what? Oxidation or reduction. If it is 0, now it's negative 1. What we get now?
Reduced.
It is reduced. Reduction. What kind of reagent, if you understood?
Oxidizing agent.
Oxidizing agent. Excellent. Again, a reason for that, you check what happened to the charge. The charge here, it is 0, and it becomes negative 1, so decrease. It is reduction. With same material, it works as what? As oxidizing agent. You just do the opposite if you see this word, agent. All right? I repeat again. Oxidation, it works as a reducing agent. Or sometimes it's called the reductant. Sometimes. So if you see this word, reductant, okay. Well, oxidizing agent, sometimes it's called oxidant. Okay? If you get it in the question, I wrote everything for you. Where is the chapter of redox? No, I have it here on the, okay? I wrote here a definition, difference between oxidation and the reduction, and how to find an oxidation number. This an example. Please study. From wherever you study, up to you. But the most important point, if I give you homework or quiz, you have to understand how to give model answer. All right? يلا يا أد.
Like, do we study this from the نسخة
Up to you. Study, inshallah, from a newspaper. The most important point, if I give you a quiz or any question, you know how to answer it. If you study from your my note, it's fine. If you study, you don't need any book, by the way. You don't need any book. Because the book, it is just guide. It is just guide. We have a lot of data. So either you study from my note or a note of your teacher, up to you. Again, when I ask you oral question, and I'm doing sometimes younger teacher day. What is this younger teacher day? For example, Adam will explain a redox for all of you. And everybody asking question. Yes, I'm doing that. You are worried? Okay, you can do it. I put the board for you, but not the screen, and you'll explain the lesson for all of us. It's okay for you? Yes, and everybody will do that. All right? So, study, solve past paper. Again, I give you key to get a star. Study daily, study once we finish any chapter, solve homework. Not because tomorrow I have a quiz at the school. By the end of the year, you will get a lot of material to do the exam in 1 hour and a half. So you have to be ready. Yes or less, يمكن. No. Chemistry 1 hour or 15 minutes or something like this. No. Paper 4, it's 45. Paper 2, it's 45 minutes. So you have, yeah. And paper 6, it's 1 hour. Yes. Okay. Who said that? From where they get this news?
6 السنة اللي فاتت بس عشان كان في
Last year because of Corona and okay, so no cancellation for paper 6. Don't give this back. All right, we have all this example in front of you in the note. You don't need any more of this data. Just this data, it is enough to study this chapter, please. It is easy chapter. And once you get a question in your exam, you have to know how to answer every question. All right? I will talk about the color change. If you read this statement and you didn't understand, I will explain later on. But sometimes we said that, I think, in the reversible, we didn't do reversible reaction together, or we did? We did? Okay. So there is color change we see in the reversible reaction and also in this kind of redox reaction. We will talk about this color change when I revise L periodic table. All right? We have color for material in halogen. So I will talk about this color when we do that. Okay? For example, here, if I'm talking about if I need to find the material, iodide ion get oxidized because the oxidation number here, what? Increases. So it works as what? What kind of agent now? Reducing agent, very good. Opposite, reducing agent. Well, sometimes it's called the what? Reductant. Very good. Reducing agent. But please, once you see this word, be careful. It is the opposite of oxidation. Or sometimes it is written like that, reductant. Reductant. Okay? It is just term in science. And this material, bromine, it is reduced. It works as what now? Oxidizing agent. All right? This one, it is oxidizing agent or oxidant. I'm sorry for that, but it is just data from your syllabus. Oxidant. A reason why it is oxidizing agent because of oxidation number, because either you say it is reduced or oxidation number decreased. So simple, chat. Anyone has a question, please ask, because I'm going now to the homework. Any question regarding redox? Inshallah, next lesson, I will start the electrolysis. All right? Because we have to finish the redox first before we start the electrolysis. Any question about the redox? Okay, let's go للhomework. Omar has this homework about the extraction of metal. Try to understand. I think you are a good student, it seems. Let's see. Anyway, if you have a problem to understand any part, let me know. Okay, let's see. We studied already the extraction of iron, aluminum, and in addition, I added the copper with zinc. They said in the new syllabus that the copper with zinc it's canceled, but really, I don't trust any of exam boards. Last year, they sent us a document about O-level Edexer. I'm teaching also O-level Edexer, not Cambridge. And they said cancel this part from organic and cancel this part from bonding, cancel this part from, for example, periodic table. I already finished that with my student. I told them I will not cancel. I will do exam paper together. If you want to follow me, it's okay. It should be canceled. And they found that questions in the final exam from the canceled part. So, okay, so we will study zinc with copper. It is just a small part in the chapter, very small, all right? Don't listen to this kind, even it is written in the syllabus. Okay, let's see what we have here in the first question to understand. They ask about the alloy. What's the meaning of alloy use? Different. If you didn't say different, you will not get the mark. So I have metal one, it is smaller in size, for example, and metal two, larger in size. Okay, that is an alloy. Well, alloy, we are talking about metals. Okay, of course, iron, it has a little bit of carbon. Okay, what we do now, Yanada, to make a stainless steel, that's my steel, Fe plus carbon. What we add as metal here, we add two other metal to get a stainless steel. We have two other metals here. She didn't get quiz in the school. Why she studied extraction of metal? She had an quiz about the rate of reaction. So prepared only for the rate. What we add, you add to get a stainless steel. Adham Dal now, because he has also quiz about the rate of reaction. What we do, yeah, mister? Chromium, not coal. Chromium and nickel. Thank you, Minna. Yes, we add chromium and nickel. I said important question. Important. How to prepare. We did that together. Just I'm revising the part. I'm revising this part. We have a lot of data about that. This part, it was June 22. June 22, paper 2. I just get the paper here. I answer, then I will send my marks scheme. Okay, it is the homework given before. All right. So alloy, it is solid. That is a diagram of solid. Why? Because we have two different metals in this diagram. I said they may ask you to choose the diagram or drawing even. If they ask a drawing, it will not be in paper 2. It will be paper 4. All right? You have to be capable to do this drawing. Again, just two different metals. One of them smaller than the other one. And any percentage, not necessarily, as you see, the black one, it's a little bit, and blank or white one more. All right? This one, it is other molecule like HCl, for example. This is different. So solid, it's closely packed when we revise the state of matter. Then this question, it's about the extraction of zinc. Even you said it is canceled. I don't care about what is written in the syllabus this year because we don't know about the final exam. It is just simple question. Already zinc will cover what we do. Roasting first step. What's the meaning of roasting, ya shabab? We heat in hot air, all right? First step roasting, next step reduction. That's it. It is so easy. Roasting, that means I add oxygen or hot air. With reduction, we add coke or carbon monoxide. And last step, it is purification. And purification already we will study mandatory in the electrolysis. All right? So if you get here to this question, well, multiple choice, you have to know how to choose the right answer. You read every step. So first step, it is a roasting. So 4, it's either B or C. All right? Next one, what we do, reduction. Where is the reduction step here? It is number 1. So the answer, it is C. And you understand, when you get this paper, you will answer using answer sheet by shading. Okay? Once we start to solve whole exam paper, I will send the answer sheet and I will tell you, maybe you will use it in the school now. You have something like this, okay? And the answer is just shading an area if you choose A. Okay? In this question, we choose C if you shade this area using a pencil. We will practice together. Next one here, it is the same year, Salma, June 22, paper 22. They are asking about rust prevention here by sacrificial protection. Who remember what is the meaning of sacrificial? فين الشباب اللي على الأونلاين? Because here, Jury, where are you today? Helia, you didn't come home. I miss all of you today. So it is so quiet at my home today. Helia or Jury, what is the meaning of sacrificial protection? Jury? Miss Jury? Yes, very good, Yemenna. Excellent answer, thank you. We're safe also. We're Angie. Jury didn't show up. She's sleeping, she's in the kitchen, she is playing, I don't know. Okay, I have this pipeline. I covered this with what? More reactive metal. Excellent, Yasif. So it should be more reactive. Usually we use either magnesium or zinc. So what is the factor causing a rust? Oxygen and water. If I prevent an attack of either this factor, a rust will never happen. So what will happen here? If the zinc is more reactive than an iron, it will react with the oxygen. Let's talk about the electron transfer. I said I will explain that once we finish a redox. If a zinc, yes, because, yes, thank you, Helia. So what will happen here? A zinc reacted with the oxygen, get oxidized, forming zinc oxide. Okay, forget the balance. But if I need to talk about electron transfer, so we break this material into what? The metal always what? Positive ion. What happened here? It lost electron. The zinc lost electron. Where does this electron go? It will go here to the iron. That means it is reduced. It prevented from oxidation. What is the rust? Material get oxidized. Like exactly, you cut your apple, your green apple, for example, and after 1 hour, you see an apple, it becomes brown. What happened? Oxidized. Same idea. Because oxidation happened with the oxygen of the atmosphere. What the material get oxidized now is zinc. And the iron, the electron will move toward the iron. So it will never rust. Important question. And it's called galvanization. Sacrificial protection, we sacrifice with the zinc or in magnesium. That is the most famous material we use. Always we use more reactive metal So it corrode instead of my option, right? It protect our option. This equation we saw also, in spite we will study that about the thermal stability last chapter in chemistry. But we understand that the calcium carbonate we added in the extraction of iron, what it gives? Calcium oxide and the carbon dioxide. Answer C. In 1 second in the exam. If you understand and you study, you have no problem. I said, if you get 36 out of 40, you are sure you get a star in this paper. Well, I need all my students to get a 40, not 36. But in case. Let's see next paper, next homework. What we have here. We continue also this sample year 23. That means you will get similar question, maybe. It is not the exam. If you think it is the exam, no way. That is just a specimen of year 23. So we practice question, maybe we get the same level or similar question. Again, the best way in IG, whatever level, solving past paper. We will solve a lot of past paper. Well, I said we will solve for UK, O level, and our Middle East. We have different variant in Middle East, and also for India in March. Okay, and USA also. Now they ask about addition or extraction of iron. You read every statement, and they said you have to read every statement carefully because sometimes they give tricky question. Here they said calcium oxide react with basic impurities. No way. El calcium oxide, it is base, right? It reacts with acidic impurities. El sand, it is acidic. We talked about a kind of oxide. You see, just changed one word. One word. Yet this statement is wrong. It should be what? Acidic impurities. El SiO2 or sand, it is acidic. All right? What is the next one? Carbon is burned to provide heat. Yes. About the function of coke. Yes. So that is the right answer. And so on. You read every statement and you check which one is the right one. They may change one letter. To avoid any mistake, practice as much as you can. Even you do wrong at the beginning, no problem. Practicing, it is the best way. Next one, really very important question. Let's explain this experiment. You will see this question in the 3 papers. Paper 2, 4, and 6. I have 2 test tubes, and I have this trough, it contains water. And I have here iron, piece of iron over here. With this painted iron, what's the meaning of painted one? Protected, very good, yes, Salma. It never rusts. Okay, I have in the test tube air. In air, we have air around us, but we can see. All right?
Which is the common factor?
28.
20?
I did it, yes, ya Layla. You didn't get 28, Layla?
Miss, I don't know why it's not A.
Because here, yes, ya Layla, we talked about a kind of oxide. Okay? A kind of oxide, if you remember when we started to talk about the aluminium, we said the metal forms basic oxide. All right? What is the property of basic oxide? If you add base to base, what will happen? Repel. No reaction. All right? Same idea. A non-metal forms acidic oxide.
Oh, okay, got it.
Silicon dioxide or our sand, it is non-metal. Silicon is over here in group 4. So it is non-metal, acidic. Okay? So if this one, calcium oxide, it's metal. It is basic oxide. It can react with base. Layla, if you add base to base, they react or they reject each other, exactly as similar charge. If you add electron next to the electron, what they happen? What will happen here?
Repel.
Exactly. So, basic impurities never react with calcium oxide. If they change this word to be acidic impurities, yes, it will be right. You get it now?
Yes, miss, thank you.
Okay. Let's go to this question again of this experiment, important question in your exam. Okay. After a few days, rust, it is a slow process. It is a slow process. It takes some time. Okay. After a few days, what they find? You will see again this question in either paper 4 or paper 6. A level of this test tube, because painted one, stays the same. But for a test tube number X, we will see water level over here. What happened? How much oxygen in the air? Around 20%, we say about 20% or 21, all right? So, the oxygen gone here to cause a rust. It is no more oxygen. So, it will cause a rust for the iron. It will react with the iron that are rust. We get again Fe2O3. That is the formula of the rust. And we may put some parts of water. That is the rust, all right? So, the oxygen gone. Its place is empty now. So what will happen? It is not osmosis. Don't talk about the pressure and this stuff. Just it will replace the oxygen used in the rust. I repeat it again. Because this place is empty now. The oxygen already reacted with the iron, and you see this material becomes brown. What happened to the oxygen? Disappeared. No more. It combined with the iron forming this material. And you see, the pure iron, it is completely rusted. All right? So where is the oxygen? Gone, disappeared, finished, get used up. So I have 20% from this height. They may ask you to calculate the height in paper 6. I will give you this question later on. How to measure this height? It is not the full test tube. It is just change this one to rust, and it will substitute at 20% of this height. What is this 20%? An amount of oxygen available in the test tube. So the oxygen used in the rust, water will rise in this test tube. Will this test tube remain because already iron protected? Clear? Important question. If you didn't get, no problem to finish the homework today. But once we finish one question, be sure that you understood. Don't be shy to ask. I repeat this question again. In our room, we have oxygen. Maybe after 1 or 2, 3 hours we are together, the amount of oxygen decreases because we take it, we breathe it. So it is the same concept. But we have here in this container water. The water will start to rise in this test tube because the oxygen it's already consumed. It's clear, ya shabab? Hopefully it's understood. Again, it's important question. In specimen year 23, you will get it in your exam, inshallah. Important question. Okay, they give you distance. They give you distance. For example, Joanna is asking how you calculate a percentage rise. A percentage rise. For example, they give you an initial distance, that is the height of the air. Okay, the height over here. Assume this one, it is 10. Okay, well, at the end now, we get this height. Okay, for example, this water is over here, okay, and this one, for example, it is 6. The water rises this distance. So you subtract this value from initial over initial, or times 100 to get as a percentage. Yani this distance, either you measure or you subtract, that is the remaining height here, it is 6, okay? So 6 minus 10, it's what? 10 minus 6, you show your work, over 10, initial, well, final minus initial, over initial times 100. We will see this question later on. But just to understand, understand the concept that the water rises to replace the oxygen for the moment until I give you this question to calculate the percentage height according to the distance given in the question, right? So in the test tube water, what will happen? Rises, and the other one will change. Next one about the extraction of aluminium. Let's remember extraction of aluminium. We have this one by electrolysis. Electrolysis, I have el cathode والanode, next lesson inshallah we'll talk about this technique in more details to understand it more. All right, I need to break down the aluminium oxide by heating to melt it. They found the melting point, how much? Who remember? Melting point, 2000 very good degrees Celsius, a unit important. So it is uneconomic. If they add this material, the found temperature melting point decreases to 900, very good, yes. So it saves very good, ya aman Allah. So it saves more than half of the energy. We are in energy crisis now everywhere. You see countries, they fight, the petrol is coming very expensive, life becomes very expensive because of the energy, okay? So they added this material, the most important point to decrease the melting point and also increase the electrical conductivity. I will talk about this part when we start electrolysis, and also to dissolve aluminum oxide. Important question. Yes, right. Now, this specimen, year 23. What we have here with it, not extraction of metal. I have here one equation about the extraction of aluminum still. It is June 21. June 21, yes. Paper 22. Let's see the question number 27. They ask about the extraction of aluminum. Once we break aluminum oxide, Al2O3, it will be what? Al positive 3, where this will go to the negative terminal, which is called cathode area. But they ask what will happen at anode. What is the anode? Positive. So which particle will go? An oxide ion or an oxygen. Let's write down an equation together and remember this equation, important. So at anode area, which is positive, we get O negative. By breaking Al2O3, we get oxide ion, O negative 2. Okay? The best way we said the aluminum, what we said, aluminum plus 3 electrons. We get aluminum metal, this is done. I will do the same way for a negative ion. So negative 2 electrons, it will give O. But the oxygen is what? Diatomic, thank you, Safe. So this 2, you never put 2 under the ion. It will be in front, where everyone loses 2 electrons. So this one, it will be 4. Or you write down an electron in the other side. Okay? Both acceptable from your examiner. All right? You write it down this way by subtraction or this way. Either one, it is right one. So we get oxygen formed at anode area. All right? Important also question this June 21. Then it's a question about the copper, el alloy. El alloy, it's a question in your exam. Even they will not ask about extraction of copper, but you get question like this. We have 2 alloys of copper. We have either copper and zinc, which is called what? Brass. And we have copper plus tin, SN. Anyone remember the name? What's called? This is called the brass, and this one is called the bronze. It is a question in your exam. If you want to study, study. If you don't like to study, it is your choice. But you get nothing by the end of the year. You like that? You like to struggle to go to the university? Just work hard from now, and you will go to the best university in the universe, wherever. Just to study. It is your duty to study. For me, I will explain every word for you, all right, regarding chemistry. So copper is mixed with zinc to get brass. It's an alloy. Then we have here also, we talked about a rust. A rust, what's the factor causing a rust? Oxygen or air. If you write down also air, accept. Water, if you write humidity or moisture, also accept, but it's better to write down water. Okay? And we talked about sacrificial protection, which it's called galvanization. Either you write down is zinc or magnesium, any more reactive metal. Don't write sodium or potassium because they are very reactive. We can't keep it. We'll understand that when we revise L periodic table. This what? March 19, exam of NG. March 19, all right? Practice question from everywhere. That is the best way again. Then I have this like a board, okay? And what they do, they said I attach here metal block, sacrificial protection. What we said, that is the iron, okay, with this more reactive metal than an iron. Let's see the question from 2 marks. He said that magnesium, it is good material to use it for this, to protect it from a rust. Copper, it is not good choice. A reason here using what? They said at the beginning of the question. Reactivity series to explain that. Simply, you mentioned that magnesium is more reactive than iron. I don't need this magnesium. I sacrifice with the magnesium. If we will use less reactive, what will happen to my board? It will rust immediately. So it will be failure from this engineer. He can't protect his object. Very good, NG. It is right answer. So simply, we write down magnesium is more reactive than an iron, but the copper is less reactive, and you get it 2 marks. All right? I have here one question, but we didn't revise the acid or base yet. But a summary of the question, I just answered this part about the rust. He said we get precipitate. What is this precipitate? We get insoluble salt. Insoluble salt. We didn't even revise the acid or base preparation of salt. But the main idea of any object, if I have whatever, I have this ring, I need to keep it protected. I need to hide it from what? From the attack of either water or oxygen. That's it. I will hide it. So I have a reaction and it forms insoluble salt. What's the meaning of insoluble? Settle down. It will settle down on my object. So what this salt will do? It will cover, it will coat. It's a kind of coating or painting even. It is insoluble material. Yes.
Does it count as a sacrificial protection or no?
No, it is not sacrificial. Sacrificial, that means this metal will react. But this material, it will hide my object, exactly as we coated with paint. It's the same concept, all right? So we have here, insoluble material will settle, will hide my object. So since oxygen or water can't reach my object, so it will prevent the rust, all right? So simply said, this insoluble material will prevent the water or oxygen to reach my object or to reach an iron. It's act as a barrier, all right? We have more 5 minutes to explain this question. What is this question? It is a specimen year 20. Specimen year 20, 5 marks. What do you want? Read the question carefully. That's the diagram of extraction of iron. We have blast furnace, and they said, describe the reaction involved. What's the meaning of description? Write down what is going on. Write down in scientific way. We have one question in paper 6, it's called the plan test. I will teach you this plan test last lesson for my tutorial before we start to solve the exam paper. How to carry an experiment. Write science, how to write down scientific way. We have measurement, we have apparatus, and this stuff. So description, so what we have here. And in addition, they are giving here a material in good order. we start to say what? What happened to the coke? We have here hot air. What we have in the hot air? Oxygen, very good. So the oxygen of hot air react with the coke. Statement, describe, or oxidize the coke. And then you support your answer with an equation and you get at least 1 mark for this statement. All right? Next one, el carbon dioxide react with more coke. We support your answer after you write down this statement. We get carbon monoxide, which is a reducing agent. Well, of course, once you write down an equation, it should be balanced. Don't write down unbalanced equation, please. So we get the carbon monoxide. What's the next step? El hematite. We just wrote redox reaction because you see here the requirement include one equation for the redox reaction. That's why I said I will explain this when we finish the explanation of redox. You write down one statement, description. El carbon monoxide reduces el hematite. And write down the equation, please. Fe2O3, we just wrote it a few minutes ago, plus a CO, of course, balanced one. We get Fe. You never write down any value under the element alone. If you write down 2 here, you get 0 out of 2. You will lose marks. You will lose marks if an equation is 2 marks, Yanada. If you didn't balance, you get 1 out of 2. You like to get 1 out of 2? I don't like. For me, I don't like.
Nervous, spinal cord, nerve.
If only 1 mark, so you will lose 1 mark.
The response to information.
Yes. You have to be more precise. You choose to continue British system. That's the British system. And we are talking about science. What's the meaning of science? You will be an engineer or a doctor, or you're preparing medicine for a patient. You like to give bad medicine for your patient? You like to do a mistake in the surgery you do? That is a mistake in the equation. Okay? Now, what we get? We get 3 carbon dioxide. This, it is a redox equation. Okay? It is mandatory to write down in this question. Now you get 4 marks. Then, they mention here acid-base reaction. Of course, I will explain it now because we understand the meaning of basic oxide and acidic oxide. What we have here, calcium carbonate. At high temperature, what will happen? It gives calcium oxide and the carbon dioxide. I said this calcium oxide, it's like your housemaid. What's the housemaid do? Clean. What's the major impurity of the rock? Sand. If you touch any rock, it is sand. What is the sand? SiO2. That was your question, ya Layla. A sand, it is acidic oxide. Acidic oxide. So we have a calcium oxide. It is basic oxide. And this one, it is acidic oxide. So it is neutralization reaction or acid-base reaction. This is basic and this acidic. What we get? Everybody is getting his stuff. Oh my God, so annoying. So I have calcium oxide is basic. Okay, أنا هتنضرب النهارده. مش مروحة النهارده. With this acidic, started to study chemistry until tomorrow. So basic oxide plus acidic oxide. What is this material? To go home. Nada, what is this called?
What's his name?
يا حول ولا قوة إلا كمان أهو.
Basic plus acidic.
What is the original name? Or very good, slag. She
Slag.
wants to go home, يا سلمى. Say it 10 times, يلا. كمان. Okay, get home. Okay, Shabab, that's it for today. We didn't finish the last part about zinc. You can do it. It is June 19. I will send my mark scheme. If you didn't get any question, please, you send your question to your WhatsApp. All right? The second. Okay, Shabab, thank you. See you next lesson. Bye. I will read it, ya Salma. Bye. يلا حبيبتي.
بس الكاثود والأنود.
كاثود
1992. هذا
براز زنك. ارجع لآخر الحصة.